Hello everybody, today we are working on factoring difference of squares. Today it's going to be very important that you have your perfect square sheet opened. Now that's attached to the Google Classroom comment. The first thing on there should be the square root of 1 equals 1, since 1 squared equals 1, and it goes on down the line. But again, you should have that open or printed out, or however you want to view it. You should have access to that as you're going through this video and as you're working on your homework problems. So what exactly does difference of squares means? Well, first of all, in math, difference is the answer when we subtract. And in this case, we're going to be subtracting two things. So it's going to be something minus something else. Now, the squares portion of this says, hey, well, these two somethings that I'm subtracting here, they're going to be perfect squares. And some examples of perfect squares that I listed out are 25, 9, 36, 1, and 49. And you should notice that they are on your perfect square attachment. Now, 25 is a perfect square because the square root of 25 is 5. Or in other words, 5 times 5 is 25. So in your perfect squares attachment, that sheet that you should have open, everything that's underneath of the square root, those are perfect squares. So if you notice, the third one down on there is 9. 9 is a perfect square because the square root of 9 is 3, which means 3 times 3 is 9. Next up, we have 36. 36 is also under the radical. This little goofy sign, that's called a radical symbol. I hope some of you remember that. The square root of 36 is 6 because 6 times 6 is 36. So again, all of these numbers are perfect squares. Okay, I'll go to these last ones quick. The square root of 1 is 1 because 1 times 1 is 1. That one's pretty simple. The square root of 49 is 7 because 7 times 7 is 49. Now, you will have access to that perfect squares sheet for the rest of the year. You should save it to your desktop. You should have it available to use. But hopefully you start to realize when you notice these numbers. For example, when 49 comes up in a problem, you should go, ooh, I know that's a perfect square. Or when 36 does. Or for example, 64. Any of them that are under the radical symbol in that perfect squares attachment, I hope you start to recognize. Okay, so factoring these is actually pretty simple. I kind of teach a different process, but it comes out, your answers will be the same. So factor x squared minus 64. Now we know this is difference of squares because first of all, I'm subtracting. It has to be subtraction. If this was plus 64, I couldn't do it. But again, it's a minus sign, so it's difference. And how do you know it's perfect squares? Well, x squared is a perfect square because x times x is x squared. So the square root of x squared is just x. And we also know that 64 is a perfect square because it's on our perfect sheet. So what we do is we are subtracting two perfect squares. And all we're going to do for this is we're going to list out the square root of the first term. So what's the square root of x squared? Well, that one's easy. It's just x. What's the square root of 64? Well, it's on your perfect sheet. The square root of 64 is 8. So I got this by the square root of 64 is 8. So I took the square root of this side and the square root of this side. I'll make this one blue so that I'm on the same page. Not jeez. Square root. Boom. Okay. So now I'm just going to use this and this. So whenever we factor difference of squares, it's always going to be my one on the left goes here and here. This was on the left side. The square root of my x squared was x. I put it on the left of both parentheses. So using that logic, we're going to put my number on the right, my 8, on the right side of my parentheses. One of my signs is plus, one of my signs is minus. Done. It's that simple. Let's try another one. This one's a little bit different. Before we just had an x squared, now we have 9x squared out front, but it's not really that different. We know the square root of 9 is on our sheet. The square root of 9 is 3. And the square root of x squared, we just said, is x. So the square root of 9x squared is 3x, because if I did 3x times 3x, 3 times 3 is 9. x times x is x squared. I would get that right there. Oh, jeez. Okay, so now I'm going to do the same thing with my 36. What's the square root of 36? Well, it's on our perfect card. The square root of 36 is 6. Again, I have two perfect squares that I'm subtracting, so I know what's the difference of squares. I'm going to set my two parentheses up. My term on the left, my square root of the left side goes first. 3x, 3x. My square root of the right term goes on the right. 6, 6. One of my answers is plus, one of my answers is minus. That's it. Now, if you decided to say, well, Mr. Adler, I want to go minus plus, that's okay too. You can switch the signs. It can be or 3x plus 6, 3x minus 6. Either one of these is correct. Doesn't really matter which way you write them. Okay, I would encourage you to pause the video and try the next one on your own. I'll wait about 4 seconds before I move forward and do it. Okay, so you should notice the square root of 100 is on our sheet. The square root of 100 is 10. The square root of x squared is x. The square root of 4 is 2. Those are my two square roots that I'm going to use. So all I'm going to do, put my two parentheses. My square root from my first term goes first, 10x, 10x. My square root from my second term goes second, 2, 2. One's plus, one's minus. But again, if you decided to write it as plus minus, makes no difference to me. Okay, last one. This one's a little bit different, and you will see a few problems like this, so please make sure you're paying attention. So before, I was dealing with x squared. I was dealing with x squared, and I was dealing with x squared. Now, the only difference is, well, now I have an x to the 4th. But you may notice, well, 4 is a perfect square and 36 a perfect square. Now, let's just back this up a little bit. We said the square root of x squared was x because x times x equals x squared. So now let's use the same logic to figure out what the square root of x to the 4th is. Well, how do you get x times something, x to the something times x to the something equals x to the 4th? Well, remember, we add exponents, so 2 plus 2 is 4. So what this tells us is, you might want to write this down somewhere, the square root of x to the 4th is x squared. That's important. So now that we know that, we can say, well, the square root of 4, well, that's just 2, and the square root of x to the 4th is x squared. The square root of 36 is 6. Again, use your perfect squares card. Now I have two perfect squares. This is a perfect square, excuse me, because its square root is here. This is a perfect square because its square root is there. So I have two perfect squares that I am subtracting in the middle. So what I can do, put your two sets of parentheses. The square root of your first term goes on the left, 2x squared. 2x squared. My square root of the right term goes on the right, 6, 6. Last thing, one's plus, one's minus, and I am done. Okay, if you have any questions, feel free to shoot